Let's get started with section 3 of chapter 9, where we're going to look at reciprocal functions. And notice this word reciprocal, it's not rational functions, it's a reciprocal function. For example, the reciprocal of this linear function, y equals x, is y equals 1 over x. So this isn't a rational function because the numerator is a constant, not a polynomial. So it's just a reciprocal. When we work in 9.4, we're going to see a polynomial in the numerator and the denominator, which will be a rational function. So we're going to graph and analyze reciprocal functions today, and we just learned what a reciprocal function is, but notice that we're going to be looking at vertical and horizontal asymptotes. And then a new word is this hyperbola, which is going to describe the shape of a reciprocal function. And then we're also going to have to find excluded values. So let's take a look at the parent function of a reciprocal, which is going to be 1 over x. And you can see its graph. The y-axis here is representing what's called a vertical asymptote. That means that this side of the shape is going to approach the y-axis but never reach, and just like this side is going to approach but never reach. There is also a horizontal asymptote where y equals 0 on the x-axis here, because on this side of the shape it's going to approach that 0 and never reach, and this side as well. So there's two asymptotes. The shape that this makes is called a hyperbola. Think parabola. Look down below. When you had a parabola, it was this U shape, right? This kind of curve, U-shape graph. A hyperbola has that same shape. Look at that. It's just sideways. And there's two of them, which is what makes it hyper. One was not enough, there must be two. So if you think about a parabola or this graph right here being a hyperparabola, that will hopefully help you remember the word hyperbola. Let's look at a couple more features. Our domain and range are going to be all real numbers except 0. We already talked about our asymptotes. There are no intercepts because of this. And we have this value that would make this fraction impossible. X cannot equal 0 because at that point the fraction would be undefined. So we call x equals 0 an excluded value. Now sometimes we have a little bit more work to do, like in this example we had to solve a quadratic, and there's two excluded values in this case. But the point is we have to set the denominator, in this case 1 over x, the denominator is x. We're going to set it equal to 0, and then if we need to solve, go ahead and solve. In this case, x equals 0 is our excluded value. Now there will be some ways to find those vertical and horizontal asymptotes as we go forward, but let's actually start with finding those excluded values. For A, B, and C, can you find the limit on the domain? Or in other words, at what point can x, or what values can x not equal? In letter A, hopefully you notice that x cannot equal 0, just like in our example. In letter B, it looks like this algebraically. In other words, x cannot equal 7. In letter C, I'm thinking of it algebraically, and x cannot equal negative 4/3. What this means is that there is a vertical asymptote of letter A at 0, and a vertical asymptote in B at 7, and a vertical asymptote in C at negative 4/3. In other words, before I drew that graph, I would go through the 0, or in letter B, I would go through 7, and in letter C, I'd go through negative 4/3 with a dashed line to indicate these asymptotes. This also tells me that my domain, x cannot equal 0, and my domain here, x cannot equal 7, and finally, you may be guessing that x cannot equal negative 4/3 in letter C. Take a look at example 2a. What happens if there's a +2 at the end? In this case, I would still first find the vertical asymptote by setting the denominator equal to 0 and simplifying. So, since I found that x equals 5/2 in this circumstance, my vertical asymptote is at 5/2, and my domain is that x cannot equal 5/2. It looks like this. I would draw a dashed line through 2.5. Now, in reciprocal functions, my horizontal asymptote is actually usually just this 0 here, the x-axis. So in all of these, my horizontal asymptote is at y equals 0. The exception to these asymptotes are when there's a vertical transformation, specifically translations. Because a normal asymptote starts on the x-axis, if I'm going to shift this thing, then that asymptote is going to shift up 2. So instead, I'm going to draw that horizontal asymptote through my 2. Since that number is 2, my horizontal asymptote is now at 2, and my range is all real numbers except 2. With those examples being explained, can you now answer the blue box on your own? What is the relationship between the asymptote and domain and range of a reciprocal function? Pause here and fill in your answer. Resume when you're ready. Hopefully you got your answer. Now let's find 2 points of this function. We want to see about its intercepts. In other words, when y is 0, what is this function? So I set my y equal to 0 and I undo. In other words, solve for x. And I found that x is 2.25. So this actually has an intercept at 2.25, right there. Then when I want to find my y-intercept, I'm going to substitute 0 for x and solve for y. We find that y equals 1.8, so there is my other intercept. Given those two intercepts, I can easily connect those points. Given my asymptote, I just copy that shape into the 2 quadrants, one being the one where the intercepts, and then the other being the opposite. They should be reflections of each other, the opposite quadrant of the asymptotes. And that's it, we just sketch our reciprocal. So here's another example. And since this is really important, we're going to work through another example, starting with our vertical asymptote, which we find is at -3. This also tells us that our domain is all real numbers, but it cannot equal -3. My horizontal asymptote would normally be y equals 0, but because of this translation, it's going to be -4. So my horizontal asymptote is y equals -4, and my range is all real numbers except -4. With this, I'm going to start building or sketching my graph, starting with the vertical asymptote at -3. The horizontal asymptote where y is -4. And now I need to find my shape. So let's see if there's any intercepts. To find my x-intercept, I'm going to replace 0 with y, solve for x. After I subtract 4, I'm going to multiply both sides by this denominator. Then undo. And I get x equals -10/4, so I'm going to, which is -2.5. So let's draw our x-intercept on that x-axis at -2.5. Next, let's get my y-intercept, where I'm going to plug in 0 for x and solve for y. Solving, needed a common denominator. Y equals -10/3, or negative 3.3 repeating. Let's write or put in our y here. Oops, right there. There we go. And this tells us that this side is going to run along the asymptote. So I'm going to draw these shapes. The only way this fits is if it goes this way, which tells me that the other side of the shape is across the asymptote. So there is a sketch of my reciprocal. We can also use reciprocals. Something like Ohm's law is a reciprocal function where V is your voltage and R is going to be your resistance, and you can find the possible answers of the relationship of this resistance. So working with electricity, electrical currents, reciprocal functions do apply. We also can transform reciprocal functions, and I imagine that this table is going to become very handy, although I'm not going to go through it piece by piece in these notes. But just make sure you know that it exists so that when we are asked to perform a transformation or identify a transformation, this chart could help you. And let me show you how. So here are some reciprocal functions, and we've talked a little bit about how these vertical translations do identify your asymptotes. But we would start with your parent function. So here is step 1. Your parent function is graphed. And then the first thing we're going to do is take a look at any multipliers. Notice that my 1 has been multiplied by 4. So step 2, I'm going to stretch and reflect by 4. So I do that first. Then I take a look at any translations. We have this +1 in the bottom. So in other words, I'm going to shift to the left one. And then I'm also going to go down 2. So I shift those as well in step 3. And then finally, I can clear up my graph and I should have my final. Now my asymptotes are going to be at -1, and my vertical asymptote comes from that translation down 2. So graphing transformations, this probably isn't something you're an expert at, but hopefully these steps will help you in class. The last would be identifying transformations from a reciprocal graph. So consider the parent function, or a formula, if you will. And you've seen these pieces before. A represents a reflection if it's negative, or a dilation, stretch or compression. H represents a horizontal shift or translation, and K would represent any vertical shifts or translations. The other thing you need to know is the parent function. If I was to graph the parent function on this, I would have my asymptotes on the axis, and then I'd have my shapes over here. So then comparing, you can see there hasn't been any flips. These shapes are going in the same direction as the parent. So let's take a look at the new asymptotes. Notice there's one here now and here. So we can see these asymptotes have shifted to the left and also down. So I have a horizontal translation left 2 and a vertical translation down 1. Except I forgot to read my axis. Let's try this one more time. Since my axis skips by 2s, I actually am shifting to the left 4 and down 2. So let's take note of what we know. We know that the numerator is going to be positive because there's no reflection. We know we're shifting to the left 4. We also know we're going down 2. The only thing we haven't figured out right here is if there has been a stretch or compression. But we could calculate for it. Since we know that H is -4, K is -2, and we could pick any point on this graph. Notice they chose the point 3, 3. Or in other words, X is going to be -3 and Y is going to be +3. With that, I have one variable, my a, in the numerator that I'm solving for. I plug in all those values, and then I solve for a. In this case, we found that a equals 5, or there's been a stretch of 5. Now, could you find the domain and range of this function now that you know its asymptotes and its final equation? Be sure to pause and fill in the box before you finish your notes today. But with that, I will see you in class for us to practice some of these. I hope you have a good beginning understanding of reciprocal functions, vertical asymptotes, horizontal asymptotes, and how to find excluded values. I'll see you in class.